guys, so in case you were absent, let me just do a quick tutorial on what we did today. And that is we discussed the natural logarithm. So jot this down if you would. Notes the natural logarithm. And so the last couple of weeks, we've been discussing logs like log. But here today, we introduced the natural log. And instead of log, the natural log, it is denoted by ln, as you can see there. That is not a 1, that is not an I. That is an L and that is an N. So it's ln. Now you should know that natural log always has a base of e. So don't copy this here in pink, but you know how for log, like if there's no number right there, you always put a 10, and that it doesn't have to be a 10. There could be like a 3, there could be like a 5, the numbers could mix and match. But if we're talking about natural log, then the thing that always goes there without exception is this number e. As a matter of fact, it's always e, so much so that people often never even write it because it's implied that it's always e. So with that introduction in place, why don't we do some properties of logs? So let me give you some properties here that pertain to natural log. So these are ln laws, and I believe there are 6 of them. So here's the first one. ln of A plus ln of B equals ln of A times B. Here's another one. Natural log of A minus natural log of B equals natural log of A divided by B. There is a third property that says that ln of A to the power of B would be equal to B times natural log of A. Here is a fourth property. The natural log of E is 1. Here's the fifth property. The ln of 1 is 0. Now let me write that a little bit nicer. That says ln of 1 is equal to 0. And then the sixth and final property says that e to the power of ln A is equal to A. So those are 6 properties there that pertain to natural logs. And from here, what I'd like to do is I'd like to do a handful of exercises where we use these things. So let's do 2 equations, 1 inversion, and then an X-intercept. So let's begin with an equation here. So let me clear all of this out. And now the goal here is to solve. Okay, so example A, let's go with natural log x plus 1 minus natural log of x is equal to 2. And so we have 2 natural logs. Let's combine them together using property 2. And this would be something like this here. Now you combine the 2 logs into 1 using the second property. And then this is where some students would be like, they run into a wall. So recall that because we're dealing with natural log, what can you put right there? You can put a little subscript e. And then what we can do here in purple is something that I forgot to mention. Badly. So let me throw this at you real quick. This idea of converting from log to exponential. And it looks like what we did last week and the week before. You see this here in purple, natural log form. You can write that in exponential form using a very familiar pattern, right? You can go e to the power of b equals a. So we have this here, this going from log to exponential. And going back to our problem here in pink, that's what I want to do. I want to write this equation, which looks like log, natural log. I want to write it like exponential. And so what would that look like? Well, let's see here. Let's go back to pink. So this would say e to the power of 2 equals x plus 1 over x. And we are trying to solve for x. So why don't we multiply both sides by x? because here in blue, these knock out. And then why don't we, anything that has an X, let's move it to one side. And anything without an X, let's move it to the other side. So I'm thinking of, maybe we can write this down here. So what do we have? We have xe squared equals x plus 1. Let me move this x to the other side. And the reason you want to move all the x's to one side is so that you could factor out an x as a common factor. Because when you take out x as a common factor, you'll notice that instead of writing x multiple times, you would have written x only once. And so then to get x alone, we divide by the stuff here in the parentheses. And this is the final result, right? You want to get x alone? We did. And you want to leave it like this. Don't turn it into a decimal. Nuh-uh. Leave it like that. Looks pretty. Okay, let's do another equation, and then we'll do something else. So, ejemplo B. Let's clear the board. Example B. Let's go with e to the power of 4x plus 7. Take away 5 equals 0. And while you're copying that down, I'll jot down the one reminder, which says ln of e, a equals b. That gives us e to the b is equal to a. It's the one FYI that we'll need. So why don't we add 5 to the other side? All right. And now what we have here, exponential, let's rewrite it in natural logarithmic form. And that would give us natural log E5 equals 4x plus 7, right? Going from exponential to log form. And now solve for x. Take away the 7 and then divide by 4. And you don't even have to write the little e because it's implied always, always. So I believe that if you isolate x, you should get this here in green, right? ln of 5 minus 7 divided by 4. Okay, so there's a couple of equations. Let's do a problem where we have to find the inverse. So let's clear here. And now the directions would say something like invert, meaning find the inverse. So let's go y equals ln of x plus ln, that's an ln, that's an ln. And then it says, Getty said, 4 over x minus 1. There it is. So we want to find the inverse. So we know that we have to switch x and y. So x would equal ln of y plus ln of 4 over y minus 1. And we have two natural logs together side by side here on the right. And based on property 1, we can combine the two logs into 1. So that'll be y times 4 over y minus 1. And this would be 4y over y minus 1. We're trying to get y alone now, right, to find the inverse. And we know that here in green, there is the subscript e, which is invisible. And we can rewrite this into exponential form, and it would go e to the power of x equals this gibberish there. So that would read, let's go up here now, that would read e to the power of x equals 4y over y minus 1. This kind of rings a bell. I think it's going to have the same structure as the previous problem or two. So let's get y alone. There's a couple of y's and there's a denominator. So let's get rid of the denominator by multiplying by the denominator. Y minus 1. Right? Y minus 1 both sides. These would be gone. And maybe you guys can distribute the orange right there. And so it would be this. It would say y times e to the x minus e to the x equals 4y. And we're trying to get y alone. So the recommendation is to move anything with a y to the left, anything without a y to the right. So I'm gonna move this to this side, and I'm gonna move that to that side. And that would say y e to the x minus 4y equals e to the x. And then we can take out a y, and that'll be e to the x minus 4. And then if you divide to get y alone, y would equal, let's see, what would that equal? Let me write this a little bit nicer. Let me write it like up here somewhere where you guys catch up. Let me erase this part, and I'll write the final answer here in the bottom left. So over here now, going over there, all right, it looks like y inverse would be e to the x over e to the x minus 4. This would be our inverse function right there. And so for the last one here, for this little tutorial, why don't we do a problem where we have to find an X-intercept? And that's pretty much what we did in class. A couple of equations, a couple of inversions, and an X-intercept. We did some more stuff, of course, but this is just, a recap summary. So why don't we find now the X-intercept? And you're given this equation, y equals, or this function, y equals 6 and then times e to the power of 4 to the power of x plus 1 minus 24, and then times in parentheses, e, close parentheses, to the power of 3 minus x. Okay, so we want to find the x-intercept. And we know that to find x-intercepts, we set y equal to 0. Yes, we do. So let's do a couple things. Let's go ahead and let y equal 0. And also see this 4, distribute that 4 to the exponent. So this would give us 0 equals 6. And then e to the power of 4x plus 4 minus 24 e to the 3 minus x. And then what we did in class was, for a situation like this, is we move the terms away from each other. So let's add the 24 term to the other side. And then we look for something that could make the equation look simpler. And I think in class we did something different, but here we're going to divide by 6. Because if you divide by 6, this guy would be gone, and this would turn into a 4. Right, so that's what we have so far. And then here, what we did is we can actually divide both sides by e to the 3 minus x. E to the 3 minus x. That's what we'll do to both sides. And so here on the left, these guys are gone. So it's just 4 equals e to the 4x plus 4 over e to the 3 minus x. All right. And then 4 equals. Now what we can do is a couple of e's here can be combined into a single e, but you'd have to go the top power, and then you'd have to go minus, right? You'd have to go minus the bottom power, which is 3 minus x. And so what you have to do here in purple is you have to distribute, carefully distribute that to that -1. And so here is what we get. 4 equals e to the 4x plus 4 minus 3 plus x. And so this is e to the 5x plus 1. And if I switch the order of the equation, it would say this here. And then what are we trying to do? We're trying to get x alone because we want the x-intercept. So here, to solve for x, what we would have to do is convert this equation into logarithmic form, right? Let's convert this into logarithmic form. getting a phone call here. So let's see. So this would be in logarithmic form, this would go log 4 equals 5x plus 1, right? In logarithmic form. Sure, there is an invisible e here that you don't have to write, but it's there. And now finish this problem, folks. Subtract the 1 and then divide the 5. And so it'd be ln 4 minus 1 above 5 equals x. But it is customary to answer as an ordered pair. If they ask for the x-intercept, then you give them the x-intercept, the x-coordinate, and then comma 0. So this here, however long this video was, it's a pretty good summary of what we did in class today. So hopefully that helped. You know, copy your neighbor's official notes, if you will, although this is pretty much a good representative of that. And then I will continue more in class next time.